All right, let's talk about matrices. The first thing we want to know about a matrix would be its dimensions, the size of the matrix. We always talk about these as rows by columns. So the number of rows by the number of columns in that order. Rows, of course, go across. Columns, of course, go up and down. So a matrix with 2 rows and 3 columns is a 2 by 3 matrix. If you say it out loud, rows first every single time, then you'll start to understand what the dimensions of a matrix really mean. Quick but important matrix vocabulary lesson is that a square matrix just means that there is a matrix with the same amount of rows and columns. So a 2 by 2 matrix is a square matrix. Let's start with the operations that require zero thought when you see them. Scalar multiplication. A scalar is just a number, not a matrix. And then you multiply that number times a matrix. What happens here is you multiply every single entry in that matrix by that scalar number. Nothing else changes. So if I take 3 times a matrix with entries 1, 2, 0, -1, then I get 3, 6, 0, -3. Every entry times 3. That's the whole rule. All right, addition and subtraction. To add or subtract 2 matrices, you add or subtract the entries in the matching positions. So top left with top left, and so on. It's very simple. There is one condition, and the ACT loves to test it. The 2 matrices must be the exact same size, or you cannot add or subtract them. You can only add a 2 by 3 matrix to another 2 by 3 matrix. If the dimensions don't match, you cannot add or subtract matrices. Let's add 2 2 by 2 matrices together. The first matrix has entries 1 and 2 in the first row, and entries 3 and 4 in the second row. The second matrix has entries -1 and 3 in the first row, and 3, 7 in the second row. To add these together, just combine the terms that occupy the same positions in each matrix. Top left plus top left, top right plus top right, etc. 1 plus -1 is 0, 2 plus 3 is 5, 3 plus 3 is 6, 4 plus 7 is 11. So adding these 2 matrices together results in a new matrix with entries 0, 5, 6, and 11. All right, now let's talk matrix multiplication. It's pretty tricky compared to those previous operations. Here's the concept that separates people who get matrix questions right from people who don't. Matrix multiplication is not like the addition we just did. You do not just multiply the matching entries. It's more complicated than that. There are 2 things you need to understand. You need to know when you can multiply 2 matrices together, and you need to know how to do that. Sometimes matrices cannot be multiplied by each other. Trying to multiply them together would be undefined. So let's learn when you're allowed to multiply 2 matrices together in the first place. On screen, we have 2 matrices. One of these matrices is 2 by 2. The other is 2 by 1. When we write the dimensions next to each other, we get 2 by 2 and 2 by 1. In order for the 2 matrices to be multiplied by each other, the number of columns in the first matrix must match the number of rows in the second matrix. In other words, the numbers in the middle, when we write 2 by 2 next to 2 by 1, the numbers in the middle must be equal to each other. So in the example on the board, we have 2 equals 2. And those matrices can be multiplied by each other. but that just tells us that we're allowed to multiply these matrices together. The shape of the resulting matrix when we multiply these together will have 2 rows and 1 column, which we find out by looking at the outer dimensions, the 2 rows from the first matrix and the 1 column from the second matrix. The outer dimensions when we write 2 by 2 next to 2 by 1. Now, if you're learning this for the first time, you're probably a little bit overwhelmed, maybe even confused. So let's review. If you're multiplying 2 matrices together, step 1 is to write out the dimensions of each matrix in the order that you are given the matrices. So we have matrix A and then matrix B. So we write out 2 by 2 times 2 by 1. Now we look at the dimensions that are in the middle. 2 matches 2. So we're allowed to do this multiplication. The resulting matrix will have the dimensions that are on the outside. 2 by 1. Now let's learn how to actually perform matrix multiplication, but first, tell me if you can multiply matrix A by matrix B. Matrix A has dimensions 2 by 3, and matrix B has dimensions 1 by 2. If we write those next to each other, we can see easily 3 does not equal 1, so we cannot multiply these 2 matrices in this order. Now, back to our original 2 by 2 matrices. Can we multiply these together? Yes, because 2 matches 2. And the resulting matrix will also be a 2 by 2 matrix because those are the outer dimensions. Now, how do we actually do this multiplication? Let's find the first term, meaning the term in the first row and the first column of the answer. We multiply the entries of the first row of matrix A by the entries of the first column of matrix B. So I multiply 1 times -1, and I add 2 times 3. -1 plus 6 is 5. That's really the key. You multiply the first term times the first term, and then you add that to the second term times the second term. So -1 times 1 plus 2 times 3. That's -1 plus 6, and that's 5, which is the first entry in the answer in the resulting matrix when we multiply these 2 together. Let's find the second entry in the first row. So we still have the first row that we're using from matrix A, and we multiply it by the second column and add them together. 3 times 1, or rather 1 times 3, plus 2 times 7 gives us 3 plus 14, and the second entry is 17. Now let's find the second row times the first column. 3 times -1 plus 4 times 3 is -3 plus 12, which is 9. Second row, second column, we have 3 times 3 plus 4 times 7, which gives us 9 plus 28 results in 37. All right, for another example, I want you to pause this video and try to answer the 3 questions before you watch my explanation. Does A times B have a solution? In other words, are we allowed to multiply matrix A times matrix B? Answer yes or no. 2. If yes, what will the dimensions of the resulting matrix be? 3. If the matrices can be multiplied together, what is the result of A times B? In other words, multiply the 2 matrices together. So yes, we can multiply these together. Matrix A is a 2 by 3 matrix, and matrix B is a 3 by 1 matrix. So A times B is 2 by 3 times 3 by 1. 3 equals 3, so we can multiply these matrices together. The resulting matrix is given by the outer dimensions, 2 by 1. And to find the first term in the resulting matrix, we multiply the first row of matrix A by the column. So 3 times 2 plus 4 times 3 plus 5 times 4, That equals 38. The entry of the second row in the result is given by the second row times the column. 1 times 2 plus 2 times 3 plus 3 times 4 equals 20. So the answer is a 2-by-1 matrix with entries 38 and 20. The last topic we want to talk about is the determinant, and this is only a concept that applies to square matrices. So for a 2-by-2 matrix, which is what you'll almost always see, the determinant is very simple. It is just given by AD minus BC. So you multiply the main diagonal, which is A times D, minus B times C. So the top left times the bottom right, minus the top right times the bottom left. Let's do an example. For a 3, 5, 2, 4 matrix, what is the determinant? It's just a definition. You don't have to know what the determinant means. You just know how to do the calculation. So 3 times 4 minus 5 times 2. That's 12 minus 10, and the determinant is 2.